Now, the next topic that we are going to discuss is something related to the deep learning, where we will be talking about the artificial neural networks, and this is the crux of the deep learning domain, because artificial neural networks, as we discussed initially, are those models that are going to mimic our human brain. This is where we will be building our own architecture, where we will be deciding how complex or how simple that architecture is going to be, and we will use it in order to do the predictions on the data. So, to set some more context with respect to artificial neural networks and how these models are going to be different from the machine learning models, let me tell you that machine learning models are kind of black box model, right? You simply build a model by specifying what algorithm you want to have, and it will do that for you. Whereas artificial neural networks is a kind of network where you will be configuring the various layers of that artificial neural network, and these models that we will be building are going to go through the data n number of times. So where your machine learning models are going to just go through the data once, and based on whatever learning that it has got, it will try to do the predictions for you. That's not how it works in case of ANN. In case of the artificial neural networks, we will be going through the same data multiple number of times, such that the model is capable enough to learn better and better on that data, and will finally end up giving us improved results. So in case of machine learning, after I mean, you do fine tune the models, but after a certain time you will see that the model accuracy will remain constant, it wouldn't improve further. But in case of artificial neural network, as it mimics the human brain, how we humans learn through our mistakes, the same way the artificial neural network will also learn through its mistake, and it will keep on improvising itself. And hence you will see that your accuracy usually keeps on increasing the more and more it learns on that data by going through it multiple number of times. So that is one of the reason why the computational power that is required in order to run a machine learning model is way too less compared to the artificial neural network. For these kind of models, you do require heavy computational resources, because going through the same data multiple times will take time also, and will consume a lot of memory also. So you need to have enough computational power to run these models very smoothly. But the way a human being learns through the experiences, the same way these artificial neural networks are going to learn through the data. It will try to learn through various combinations of variables. So it will try to relate to the relationships between those multiple variables on its own, and it will be able to learn better onto that data. So that is the reason why we have that term as artificial neural network, because neural networks, the way they function in our brain, the same way these are also models that will be functioning by interconnecting the perceptrons into the network. Just like our brain has neurons, these models have an element called as perceptrons, and these are going to act like a artificial human brain. That's the reason that term artificial neural networks. So in case of the artificial neural network, there is something called as feed forward propagation and backward propagation that I want to discuss with you in short. Now, when the uh, artificial neural network model is built, there are multiple layers that it works upon. Okay. Now, the very first layer that we have in this is the input layer. Then we have a series of hidden layer, and then finally what we have is the output layer. So this is the simplest structure of any of the artificial neural network related model. So the input layer is where we feed the data to the model, where those various variables are received by the model, and then there are series of hidden layers where all of these perceptrons are interconnected. There are weights allocated to each of the perceptron or the variables in order to decide how each of the variable in that combination will be impacting the predictive power of that model. And then finally, with the help of activation functions that you apply onto the neural networks, you will be able to derive what is the predicted value for a particular test observation from the output layer. So that is the sequence that we have. Now, what we are mainly able to, manipulate over here in order to create our own architecture, that is the hidden layer. So you can decide how many hidden layers you want. You can decide upon what should be the activation functions that should, be used in order to work upon building that neural network. So there are these kind of segments that you can modify into the neural network to make it like your own architecture. And that is the reason why we also call it as the ANN architecture, because it every model that you build for ANN could be different from each other. And all that we want to ensure is that it performs multiple epochs through the data in order to go through the data multiple number of times and learn better and better on it. An epoch is a single cycle through the entire data. We can decide how many epochs the model is going to perform. It could be 50, 100, 1,000, whatever. And depending upon the number of epochs, the complexity of the model goes on increasing. Now, coming towards what is this feed forward and backward propagation that I had mentioned. Feed forward propagation is the concept where you will be performing one let's say a cycle of learning. So from the input layer, the data will traverse through those various hidden layers, and then finally through the output layer you'll be ending up getting some output, right? So that single cycle that you are going to perform is known as your feed forward propagation, because you are moving forward into that particular network. But now let's say that after getting the predicted value from the output layer, if the predicted value is correct, it matches the actual value, then fine. But if it is an incorrect value or prediction that we have got, that is where we need to perform the backward propagation. And in case of the backward propagation, we will traverse in the opposite direction from the output layer to up to the input layer. So basically, what we try to do is we back propagate the errors. So those observations which were kind of misclassified by the model, we will take them backwards. We will try to reallocate the weights of all of those variables and the observations that we are going to work upon, and we will ensure that this time the model learns better on them so that the model is able to predict them correctly. So we propagate the error backwards into the architecture, and then the feed forward is once again performed in order to help you get an improved kind of model. So this is the cycle where we traverse in the opposite direction from the output layer to the input layer, and that is known as the backward propagation. Backward propagation helps you change the weights of the data, and that is how your model keeps on improvising. So, as I said, we mimic the human brain, how we human beings learn through our own mistakes. The same way, the model is also going to identify the errors on its own. It will back propagate them and it will try to improve upon them. So, that is what your feed forward and the backward propagation is all about. And there are several activation functions that you can make use of in order to work upon the neural network. Apart from the activation functions, you have several loss functions also, which can be altered in order to see which is the loss function that works the best for you. So all of those kind of changes you can make into the neural networks, and you can build a good artificial neural network that can be used for, again, both kind of problems, be it your regression problem or a classification problem as well. So you can try solving both the kinds of problems with this artificial neural network. And if you ask about what kind of data it is suitable for, then usually it is suitable for the structured kind of data, similar to the regression or classification data that we would see as part of the supervised machine learning. But yes, having said that, there are other types of neural networks that fall under the deep learning category, where we have the convolutional neural network, which is a kind of neural network that is suitable for working upon images or videos related data. So we have the convolutional neural network, which is quite often used when we want to work upon images or videos kind of data, because these models are more suitable for such unstructured data. And in case of image related data especially, you can make use of the CNN architecture in order to perform image classification, classifying the given image into several objects, or even object detection kind of things you can perform with the help of this technique. But this is the category, or this is the algorithm that could actually set your foundations with respect to the computer vision, which is one of the branches of the artificial intelligence. And this set of algorithms will help you understand the transfer learning related models like the ImageNet, ResNet, VGG16, 19, etc., which are quite often used in the industry, where these pre-trained models are just fed with our data, and we use these models in order to get good results on our data. So convolutional neural network, as I said, is something that will set our context with respect to the computer vision as one of the branch, right? And it's a very booming field in the industry right now, because it helps you perform a lot of tasks related to images. And apart from this, we also have something called as RNN and LSTM, which is mostly used in order to work upon text or speech related data, because that's where these algorithms are suitable. So RNN is your recurrent neural network, and this is something that will set your foundation with respect to the natural language processing domain. And what is natural language processing? It's another branch of artificial intelligence, where we try to express something in natural language, which the machine will try to process, and it will act accordingly. So be it your sentimental analysis, or your document translation, or your AI chatbots, all of these are nothing but examples related to use cases in the natural language processing domain, where you would be working upon the text or the speech kind of data. And LSTM, the long short term memory, is nothing but a extension of recurrent neural network. So recurrent neural network has a um, kind of shortcoming in terms of the memory part, and that's where the LSTM kind of model comes with the memory aspect, which helps you build a better model. So that is something that again is related to the artificial neural networks, and all of these things together make up the deep learning category for you, which is a subset of the machine learning, right? And all of these models are complex models, because they all go through the data multiple number of times by performing several epochs, and um, they definitely learn better on the data, tend to give you better outputs, but at the same time they require a lot of computational power as well. And you will usually find that these set of algorithms are implemented onto GPUs in the industry, and your normal machine learning models could still be implemented on CPUs. But where it comes to implementing the neural networks kind of, or let's say the deep learning kind of setup, we would prefer having a GPU, because we would want to get the task completed as soon as possible. So we would definitely use all the possible resources at that time and get the task implemented. So yeah, these are certain things that I would like you to know about the deep learning side as such, where artificial neural network remains the crux of everything. And CNN, RSTM, sorry, CNN, RNN, these are all just the types of neural networks that we have, and they help us work on different kinds of data with different logics as such, and that is how they become different algorithms under the deep learning category. So yeah, we have tried understanding the various different algorithms that fall under the um entire machine learning umbrella, and we have tried deep diving into some of the important topics as part of each of the major subcategory. So these are the algorithms which are commonly used in the industry, can help us solve different types of problems, and these are the kind of algorithms that you should look forward to when you are building your own machine learning projects and deploying them for the client. And there is more of math towards each and every algorithm. Although I have tried touching upon some of the aspects or some of the important pointers related to each of them, in order to understand all these algorithms in detail, you will need a thorough interest into the mathematics or statistics to understand what exactly happens behind the scenes in order to get you those results. But from an implementation point of view, it is as simple as changing the algorithms onto the same data. So today, if you are solving a regression problem, you have those n number of algorithms that we had listed, right, as part of the regression category. So you can use either of them, and we can sorry we can use either of them, and so we can make use of either of them, and we can get rid of. Yeah. So we have seen a lot of algorithms that are a part of the regression category. So we can make use of either of them, and we can try solving any of the regression problem. At the same time, if you are dealing with the classification problem, you have multiple algorithms that you can apply. So all I'm trying to emphasize upon is, do not stick to a single algorithm as such. When you are solving a particular problem, try out multiple algorithms so as to understand which is the one that suits the data more efficiently, because for different data sets you will see different algorithms give you different results. So it's a game of identifying which is the algorithm that suits this particular data set more efficiently, and using that data set in order to do any of the future predictions that you would like to do on the upcoming test data that the client will be giving you. So, with that, I hope you all had a good time understanding the fundamentals of the machine learning umbrella. And I hope you could get a gist of these various algorithms that we have discussed as part of this masterclass. I look forward to connecting with you all in the next masterclass.